Well, my name's John Orchard, DOE, federal point of contact. Our technical point of contact is Peter Swift, and I think Peter might be with us too. Our topic is FC-4 used fuel disposition. We got spent fuel and waste disposition, I guess, is our new title. FC1 is fuel cycle 4.1 disposal, and our second part of the topic, FC 4.2, is storage and transportation. Let's see, how do we change the page? Can you move that to the next slide, Drew?
Yep, just let us know when you're ready to change slides and we'll move them.
Yeah, okay, thanks. So the mission for the DOE Office of Nuclear Energy is here. You've probably seen that before. The mission for spent fuel and waste disposition, which is us, is identify alternatives and conduct scientific research and technology development to enable storage, transportation, and disposal of spent nuclear fuel and waste generated by existing and future nuclear fuel cycles. Next slide, please. We work with the national labs, and these are the national labs we work with here. Next page, please. For the spent fuel and waste disposition, our grand challenge is to provide a sound technical basis for the safety and security of long-term storage, transportation, disposal of used fuel and waste from the nuclear energy enterprise. And this supports the establishment of spent nuclear fuel management and disposition pathways. Next slide. Within spent fuel and waste disposition, we have two divisions. One is disposal, and the research needs for disposal is provide a sound technical basis for assurance that the U.S. has multiple viable disposal options available when national policy is ready. And then identify and research generic sources of uncertainty that challenge the viability of disposal concepts. Increase confidence and robustness of generic disposal concepts to reduce the impact of site-specific complexity. Develop the science and engineering tools required to address the needs above. And our other division is storage and transportation. And our research needs there are to develop the technical basis to demonstrate used fuel integrity for extended storage periods, for fuel retrievability and transportation after extended storage periods, and for transportation of high burnup fuel. Next slide, please. This is some graphs of or figures of generic repository and the candidate geologies that we're looking at for a generic repository. And on the lower side, we've got barriers to waste isolation, which is where most of our focus is on. We have the natural barrier system, the engineered barrier system, and then the actual waste form, which is typically glass or hard ceramic. Next slide, please. Our storage systems here, there's the fuel itself, which is in bundles. In the reactor, they're bundled, and we store them in the bundles. We put the bundles in casks, as shown on the bottom left, and we store the casks in isophases, which have components of the pad, the rebar, and physical protection, and we have monitoring systems. Next slide, please. This year we have call for 2 supporting R&D proposals are being solicited for in the used fuel disposition area, FC 4.1 disposal, and 4.2 storage and transportation. And these will be university-led R&D projects for up to $800,000 and up to 3 years duration. Next slide, please. Specifically in FC 4.1 disposal, we're looking to develop new technologies, models, and validation techniques to support the permanent disposal of spent nuclear fuel and high-level radioactive waste for a variety of generic mined repository concepts in various rock media, including the following: waste package failure modes and material degradation processes, new techniques for in situ field characterization of hydrologic, mechanical, and chemical properties, alleviating post-closure criticality concerns, and novel buffer materials, engineered natural system component properties, and failure modes. And then in 4.2 storage and transportation, we're looking to develop novel technologies for mitigating chlorine-induced stress corrosion pitting and cracking to improve the reliability of long-term storage and maintenance of the spent nuclear fuel storage canisters. And I think that's the last slide. Yes. Are there any questions?
John, we're waiting for questions. Please do submit those to the question and answer box on your GoToMeeting application.
The scopes for both the FC1 and 4.1 and 4.2 are very similar to last year. So,
John, we do have one question.
okay.
For FC 4.2, what type of steel are you interested in?
Well, it's the steel, the stainless steel. The canisters are fabricated. It's the canister walls we're looking at.
Is it possible to propose a project that is scheduled for less than 3 years?
Yes.
Does novel cask material, is that area of interest?
No, we're not looking for the actual cask material. We're looking at protection for the cask material as it's produced by the cask suppliers. The cask, meaning the canister, actually. The canister, protection for the canister, using the existing material that the canisters are fabbed from.
Are international collaborations welcome in these work scopes?
I'm sorry, can you repeat that?
Are international collaborations welcome in these work scopes?
Yes. I think there are restrictions, and I've forgotten what they are. Maybe you remember, Drew. But
the restriction is that NEUP, NEAT, NSUF dollars can't go overseas, but you can partner with an international partner who makes some type of an in-kind contribution or is in an advisory role.
okay.
As for the technique mentioned in FC 4.2, are modeling and simulation of interest to the program?
Yeah, modeling and simulation to support yes, the technology. Yes.
For FC 4.1, are you interested in interactions of microorganisms with materials in a generic repository situation?
I don't know. Is Peter on the line?
He is. Let me add him in really quickly. Peter, you'll need to put in your audio pin so that I can find you and unmute you. So we'll put that question off. Let's move to the next question. Are cement-based materials or barriers of interest to FC4?
Are you talking about FC 4.1 as a
The question
buffer,
doesn't
or FC
clarify that.
4.2 as an inhibitor?
We'll look for a clarification from the individual that submitted that question and move on.
Okay.
With regard to storage, are you looking for solutions applied to existing / fielded canisters or new storage canisters?
Both. Some of our concept is that yeah, if we can apply some sort of inhibitor to the new ones, that would be useful. And the existing ones, which is probably more of our focus, is at some point in time we're thinking that we might have to relocate the existing ones, and it would be good at that time to have some sort of inhibitor to apply to them, the canisters. I'm not particularly looking for application in situ with the canister and storage inside the concrete overpack. I'm looking for something I'm more focused on something at a time when we take the canister out of the concrete overpack to relocate it somewhere.
Okay, we do have Peter on the line, I believe. Peter, are you there?
Yeah, I'm here. Can you hear me?
We can hear you now.
Good. Yeah.
You want to take that, I'll repeat the question for 4.1. Are you interested in interactions of microorganisms with materials in a generic repository situation?
The answer would be yes to that, to the extent that, I mean, it would need to fit the other aspects of the existing call, but yes, definitely.
For RC 4.1 or FC 4.1, would you consider metallic waste forms, or is it just ceramic and glass waste forms?
We're actually, our greatest interest would be in glass and also in existing spent fuel, uranium oxide fuel. There is the separate waste forms call that will be looking at sort of experimental and unproven waste forms. We'll look at them, but they'd be likely to be referred over to that call instead.
For FC 4.2, what TRL level of technology is the best fit for the call?
I think we're at the early stages, so I think we're kind of open on that one.
I'm going to move back to a question we already asked. This is for FC 4.1. Are cement-based materials / barriers of interest to FC 4.1?
Yes.
Would optimization techniques to expedite removal and clearing decommissioned sites be of interest?
Not in this call, no.
Are novel concrete materials for the overpack for disposal with physics-based modeling of long-term aging considered?
It's not a high priority, but to the extent they fit the call, we would definitely take a look at them.
In the language of FC 4.2 in the draft work scopes, you mentioned sprays, coating, and weld deposition techniques. Are you placing more weight on these 3 techniques, or other techniques will be equally considered?
We're not placing more weight on these techniques. These were just some examples, but we'd probably be more interested in other techniques, novel techniques.
In FC 4.2, is low-level radiation waste being considered?
No.
In FC 4.1, are you only interested in spent nuclear fuel research, or are single-phase ceramics or multi-phase ceramics as potential waste forms also of interest for the program?
Our primary interest is in disposal of existing wastes or treated forms of existing wastes. We recognize that much of the spent fuel in this country will be disposed of without treatment, without processing. So certainly spent fuel is a high priority. Existing plans call for vitrification of tank wastes, so that's a high priority. We'll certainly consider viable alternatives to vitrification waste forms, but our interest is on existing waste rather than future waste from hypothetical future waste streams, future fuel cycles.
What kind of buffer materials are you interested in?
Our well, good question. All right, bentonite is a standard. We're interested in buffer materials that have high longevity, high durability over geologic time, hundreds of thousands of years, that are sorptive and are of very low permeability, that are tend to heal their own fractures, and that are capable of withstanding temperatures up to 150 to 200 degrees C. You won't find that in the call, but since you asked, there are some answers to that. Bentonite meets all of those except for the high temperature end of the range.
For FC 4.2, what's expected for the proposals to this call that's different from previously supported projects such as the cold spray projects funded in FY 2018?
It's very similar to those. Cold spray was just one type of inhibitor. The cold spray that we were looking for there, I think, was more focused on repair of existing cracks, and what we're focused more now on is inhibiting the initiation and growth of the cracks and the pits. So the nuance is a little different.
John, that appears to be all the questions that we have. Oh, there is one more. All right. Are new materials or barriers for deep borehole disposal of HLW of interest to FC4?
John, I'll take that one. Deep borehole disposal itself is not currently in the DOE R&D program. So the answer would be only to the extent that they were also applicable to a deep mined repository.
We will hold on the line for about 15 to 20 more seconds to take any further questions. John, Peter, I'm not seeing any more questions. This will wrap up our FC4 session. We will return at 2:30 p.m. to discuss the RC1 new structure materials for molten chloride salt fast reactor applications at 2:30 p.m. Please join us then. Thank you.